Alright, this is our second video on fractions, and I left the original one up there. When we're talking about fractions, we're talking about oftentimes values that are less than 1. These are called proper fractions. That's because the numerator is smaller than the denominator. But you'll see in our next idea here, in dividing fractions, that oftentimes we get an improper fraction. So what are we talking about? Well, first of all, how do we divide fractions? If I have 2/3 and I want to divide it by 1/2, if we were dealing with integer numbers, you would use the divide box for doing that. But I don't think you've ever seen this in any arithmetic book in dealing with fractions. That's because there is no operation that we can do like that. But there are two legitimate operators for division. The fraction bar, as we looked at, this means division, and of course the divide box. This little thing that they like to use as an operator is not an operator. This is a symbol for division, not the operator for division. And that's because, I say that because by definition, the operator for division must also be a sign of grouping. It groups the numerator stuff and the denominator stuff. And here it's obvious what gets grouped, the divisor and what's being divided. This does no such thing. They introduced this in grade school, so they can do this because they don't get into fractions. They teach you division before you even get to fractions, so they need an operator like how they use the x for multiplying. But this is not legitimately an operator. Okay, I'll get off that little pedestal. So how do we divide fractions? I want to divide 2/3 by 1/2. So we make a compound fraction out of it. I'm not going to waste, well, it's not a waste. I'm not going to use video time to explain how this works, but there is a very neat reason why this works. Generally what we're taught is we take the divisor, we invert it, meaning turn it upside down, and turn this division problem into a multiply. We can do that really because the fraction is a division problem to start with. So we're dividing a divide and inverse operations, and there's other reasons why this works, but this is the typical process. So in reality, we really don't divide fractions, at least in the traditional method. We turn a division problem in fractions, we turn it into a multiply problem by inverting the divisor. Inverse means upside down. Okay, so now we can multiply. We get 2 times 2 is, not 2, is 4, and 3 times 1 is 3. And here's a great example of an improper fraction. The numerator is bigger than the denominator. Now, it might be tempting to say, well, okay, this is the same as 1 1/3, and put it into a mixed number. Mixed numbers are great if you're sawing up lumber out in the back patio, making a picnic table, or measuring, some wood project, because this is how, 1/3 of an inch, 1/3 of a foot. We deal with mixed numbers all the time with those kind of measurements. But when you're doing calculations, this is a very unfriendly format for a number to be in terms of calculations. So leave it as an improper fraction. Okay. All right, let's get down to adding and subtracting. And the process is the same. Okay. The evaluation, of course, is different, but the process is the same. Now, when fractions have the same denominator, Notice that we did not add the denominators. When the denominators are the same, and with adding and subtracting, all the arithmetic takes place in the numerator anyway, regardless. Okay, but we just add the numerators and put it over the existing denominator. And of course we recognize that number when the top number and the bottom number are the same, that equals 1. Okay. And if we were subtracting, then we would subtract one from the other, and in that case we'd get 1/3. All right. That's well and fine if the denominators are the same. Where the trouble comes in is when we are adding two fractions and they do not have common denominators. You cannot just add the tops and the bottoms and come out with 5/7. That's not the correct answer. And the reason really has to do kind of with the area of the thing. Remember what the denominators are telling us. The slices up here are in 1/3, where down here in 3/4 they're 1/4. They're not the same kind, so we can't stuff those two together. We need to determine a size that both 3 slices and 4 slices will fit into evenly. Now there's any number of ways to, well, not any number, but there's at least 3 ways of adding or subtracting fractions. And I'm going to show you perhaps one of the quickest ways. And we're going to use 2 principles. We're going to use this principle right here, where when the numerator and the denominator are the same, we get 1. And the other principle in math is that 1 times any number does not change its value. It equals whatever the number is. So multiplying anything by 1 does not change its value. So I look at this fraction, I say, well, what does this fraction over here have in its denominator that I don't have in this one? Well, I don't have any fourths. If I could put a 4 down here, then I would get it. But I can't just add something to the denominator. I must add something to the numerator. Well, what if I add 4/4? This is just another form of 1, and I'm going to get rid of this so we're out here. There we go. It gets confusing. I'm multiplying 2/3 by 1, so I am not changing its value. I'm only changing its form. And I'm going to do the same thing over here. This one does not have a 3 in its denominator, so I'll put a 3 down here, and I'll put a 3 up here. Now, we need to do the multiplication, because this means multiply. We need to do the multiplication before we do the addition. So 4 times 2 is 8, and 4 times 3 is 12. 3 times 3 is 9. 4 times 3 is 12. We get 2 fractions that have a common denominator. Now we can just simply add these together. We know that it's going to be in 12ths because we only add the numerators, and we get 17. And it's an improper fraction in this case. And notice how, no, I don't want to go there. So this is good. Now the only difference between this and subtraction is that when we get to this point, this would be a subtraction. And this would give us a -1, but not 17. This would become a -1/12. But all you do is change the operation up here. The process of doing this. This is very neat. There's a more traditional way of doing it, but you come up with a common denominator ahead of time and divide the bottom into it and multiply by the top number. It has a divide and multiply step, where here we just have a multiply. Much easier to do. Okay, that's it for this video, and maybe we'll work a few problems in another video.